Hi everybody, my name is Tori Earle and I am an Extension Specialist for 4-H Youth Development with the University of Kentucky's College of Agriculture, Food and Environment Cooperative Extension Service. We're here today to introduce you to this year's 4-H National STEM Challenge, which is called Mars Base Camp. If you hadn't noticed, this year we're doing the National 4-H STEM Challenge training just a little differently. This second activity is called Red Planet Odyssey from the 4-H STEM Challenge. In our second activity in the Mars Base Camp Challenge, we're going to try to see how we can maneuver around on Mars. And this is called Red Planet Odyssey. During this activity, participants will build a small rover, and there are instructions given with the rover as to how a suggested way to put it together, but this will also be a chance for them to experiment a little bit and try some different things. In building the rover, I'm going to try to give you some tips and some things that I've learned in putting one together that might make it a little easier for you and get you maneuvering around more successfully. In addition, the information that they determined from Landing Zone Surveyor and the landing zone cards that they got in the previous activity, they are going to be challenged with building an obstacle course based on those features that might be in existence in the area that they landed on Mars. In doing this, just use everyday ordinary things from around the house or around the classroom. And you can use books, you can use just about anything to create an obstacle for your rover to get over. What we're going to do now is move into looking at the parts that are in the kit for the rover. And again, like I said, I'm going to try to give you some tips of ways to make it a little easier to assemble. So let's get started. As we get started, this is what the rover kit looks like as it would come out of the experiment kit, either the educator or the family kit. And it's boxed up all nicely together like that. And I've got the parts laid out right here. This is your base or your chassis for the rover. It's got 4 wheels, 2 axles, 3 gears, several small screws, an electric motor, a motor anchor point or holder, and a battery holder. Now you will need 2 AA batteries to go with this in order to make it run. Several of the things that I discovered about this kit are that you're going to have to apply some force in a couple of places to get some of the gears on or to actually to get the screws to start in. The kit itself does come with a small screwdriver. My recommendation would be to probably get you something that's a little more substantial that will hold on to the screws a little bit better, because the screws are tiny and if you're not very careful with them, they do have a tendency to strip out. But the instructions for the rover are included right here. It goes step 1 through step 5 to get your rover put together. So we're going to look through those and get this rover put together in order for it to move around. Now, one of the ideas behind doing this Red Planet Odyssey activity is for participants to think about the engineering design process. And that process is listed on page 20 of your facilitator guide, 20 and 21, where you start by asking and identifying the problem, imagine or brainstorm solutions to what you're wanting to do, plan by putting together a couple of 3 sketches or ideas as to what the good ideas that came from the group during brainstorming would be. Create, you build a working model or a prototype that follows those design characteristics that you wanted to have. You test, which you would evaluate through the testing and collect and analyze data based on what the test reveals. And then you would improve on the design that you've made. So keeping those in mind, this is the engineering design process, and we're going to get started putting this rover together. According to our instructions that came with the rover, step 1 is going to be to install this long screw, the longest one in the kit, into the medium gear. You'll see there's 3 different size gears here. The medium gear actually has 2 different teeth gears on it. You put the screw, start it into the side with the smallest gear, and then take your screwdriver and start screwing it in like that. Once you get it all the way through, the smooth shaft on it will allow the gear to turn. Then, looking at your chassis, the medium gear goes in the second hole on the side of the board. One of the things that it does tell you is to make sure to leave space for rotation. If you look at the chassis itself, there's a small hole that will be on the end where the motor will be attached, and there is not one on the end where you will attach the battery holder, if you're going to follow the design that is listed in the instructions. So, looking at this side with the small hole facing towards you, turn the rover to the right with this side up, and you're going to install the gear in the second hole right there. So you'll put the gear on top with your screwdriver. You're just going to screw it into that second hole and make sure that it will still turn freely. You may have to back it out just a little bit. Make sure it turns freely. The next step it gives in the instructions is to install the axle. My suggestion is going to be that you would install this large gear onto the axle first, which it gives you in step 2. Because as you would install it, you're going to have to put the axle in, and then you're going to have to put some pressure on it. So I would recommend setting the axle on the table, taking both hands, one on either side of the gear, and pressing it down onto the axle itself. This allows you to have a little smoother and a little easier transition of the axle on there. Then you would install the axle through the holes on the bottom of the chassis, lining it up so it goes all the way through. And this also allows you to make sure that you got your medium gear installed in the correct hole on the side, because that way it will turn the large gear, which the motor itself is going to turn the bigger part of the medium gear, and the smaller part of the medium gear is going to turn the gear that's on the axle. Now we got a little bit of, maybe got the gear a little too far on there, so I'm going to take it and bring it back out just a little bit. But you want to leave space on either side for your wheels to attach. Make sure to get it in there, make sure the gear meshes and turns freely, and it's going to look kind of like that when you get done. Now, step 3, or again in step 2, it gives you an indication to install the small gear on the motor. It's this small gear with your motor right here. My suggestion, put the motor flat on the table, start the small gear onto the motor shaft. It's going to take a little pressure to do it, but then, just like you did with the gear on the axle, press it down, and my suggestion is make the motor shaft coming out flush or even with the outside of the gear, and you could put it on the table and push it down just a little bit more like that. Now, before you would install your motor, this is one of the tips that I have figured out that makes things work just a little easier. The 2 tabs that are on your motor right here, they're flat out to the side, they're parallel to the top of the motor. I would suggest very carefully bending each of those tabs up just a little bit so it looks kind of like this, or like that. 2 tabs bent up. This will allow you to put the wires through and to wrap them a little tighter so they will stay in place. Step 3 of our process indicates that you should put the motor onto the chassis of the rover itself, and the suggestion is to use these 2 holes, the very back of the chassis, to start the motor hold down mounting in, and then as you would put it on, you're going to use the corresponding holes that would line up on the rover chassis itself, which would be right here and here. I would suggest first putting the smaller screws into, if you can hang on to them. They are a little tricky. Put one of the smaller screws into one of the holes on the motor mounting band, and then screwing it in to the hole on the back, first hole on the back of the rover chassis. Then take a second one and put it in right beside it. Now, if you're using the screwdriver that came with the kit, I will do that on these next 2 just to show you that it is possible to do it. But before you would put any more screws in, I'm going to suggest sliding the motor through, making sure that it meshes up, and you can turn the large gear and see if all of your gears are turning together. Line everything up to where it fits nicely, and then take the screwdriver that came with the kit, press in, find the mounting hole that will work. There are several in the chassis of the rover itself. So as you can see, the small screwdriver will work, but it's a little bit tricky to use it sometimes, a little precarious. So what I'm going to do is I'll turn it around this way so you can see the process on this side, and just use the screwdriver and then tighten all the screws down. Make sure that the motor is held in there firmly. And that should hold in there fairly tightly. You'll see you've got 4 screws left. Now those 4 screws left, 2 of them are going to be used for mounting the battery holder. The suggestion in the instructions itself suggests that you might mount a screw right behind the motor to keep it from sliding backwards. I found if you get these on the motor mounting bracket screwed down tight enough, the motor's not going to move. So now let's look at mounting the battery compartment. The battery compartment will sit on what you could consider either the front or the back of your rover, depending on if you want it all-wheel drive or not, or if you want it front-wheel drive or rear-wheel drive. We'll take 2 of your screws, and I'm going to go back to my larger screwdriver here. Line up the mounting holes in your battery holder, and you can choose which ones you want to use. I'm going to use one right there, and then I'm going to use one that is 2 holes down from it. I'll screw them into the battery holder. The screws will still rotate. And then I'm going to line this up and screw it down to the chassis itself. If you notice, I did change the position of where I first was intending to put that screw from the outermost hole to what would be considered 1, 2, 3, 4, and 5. The 2 and the 4 hole instead of the 1 and the 4. You could choose to use 3 screws if you wanted to. 2 will hold it sufficiently. From there, we're going to wire up our motor. This is another trick or a tip that I'm going to give you. Is you would push wires down underneath the chassis of your rover and then bring them back up through the hole that is closest to the motor, the round hole on the chassis. You notice that each one of the wires is already, the insulation is already stripped off of it, but it's not completely removed. This is handy because the wires themselves are stranded wires. They'll fray if you're not careful. So my suggestion, carefully remove the insulation off the wire and then immediately twist the wire so it makes it more of a solid wire and you don't have strands coming out all over the place. Same thing with the black wire, and you can do it in either order, black first then red or red first then black. The operation of this is it's using 2 AA batteries, so this is a direct current motor or DC motor, which means that it doesn't matter which lead goes on which pole or tab on the motor. It will make a difference as to which direction the rover moves, but it doesn't make a difference which direction or which one you hook them up to on either one. My suggestion would be just decide which one you want to do and just do it consistently with all of your participants. So I'm going to put the red lead on the tab facing what I would consider the back of my rover. And if you notice, I'm having to twist these a little bit more because they are very, very small wires, and you want to get them through there, and it's still not twisted quite enough. So this is a tricky part. So I think I got it twisted enough this time. I'm going to put it through here, and then what I'm going to do is I'm going to wrap my copper wire around the insulation, around the red insulation going into my motor, retwist the black wire, and carefully run it through the other tab on the other side and do the same thing. Just wrap it around the insulation on the wire itself. And it'll look something similar to that. Before securing the wheels on the axle, again, this is a tip that I recommend. Before securing the wheels on the axle, after you get the leads for the motor hooked up, I would suggest that you make sure the switch for your battery box is in the off position. Then install your batteries, and just to make sure that everything is working correctly, test it and see if your motor turns your axle. As you can see, and here, it is working. So we turn it off, and we remove our batteries. Then we're going to install our wheels on our axles. Simply press the wheel or press the axle down into the wheel, and they do the same thing on the other side. Making sure that your wheels and axles spin freely and don't have a lot of friction on them. Got some freedom there. We want to move them in just a little bit, but we are spinning freely. Then take your front axle, install it through both holes, and then you can press the axle into the wheel itself on both sides, making sure to leave, again, enough freedom of movement for the axles and the wheels to turn freely. And there you have it. There is your rover. Hey, you may ask about the bare wires here. There's not going to be enough current to provide a shock for anybody, but a suggestion that I might offer is, especially if you're going to reuse these for various purposes, those are very, very fragile wires, but take you a small piece of masking tape and secure over the top of those wires and cover up your tabs. That way you don't have non-insulated wires that are exposed. So something like that. And the reason I say to use masking tape is because it's easy to remove and won't necessarily damage the wires as you take them off. Now, we reinstall our batteries. According to the diagram that's in the battery holder, and we'll see if our rover moves. And at this point it does not, so I've got to see if I've got the batteries in correctly. I do, so let's troubleshoot. Why is our rover not moving? We'll take the masking tape off, and we'll see if we still have a good connection. There we go. And it may have been that in putting the masking tape on, we may want to look at a little different configuration. So we'll put it over the top of one wire. Then we'll put it over the top of another wire. That way they're not together. We'll see if this, there we go. And there goes our rover. Now, you'll notice it's pretty quick. You may want to try to think of some ways to slow it down. I have experimented with a few ways and not found one that is truly successful yet. I was able to do a configuration where I switched this large gear and this small gear and left out the medium gear. It did slow it down some, but ended up having to push it to get it started because there was not enough torque in the motor itself to cause it to start moving. So as you would have your participants design their obstacle courses, you might think about the speed that the rover actually runs. Now, another thing that one of our Science, Engineering, and Technology Leadership Board our members came up with They discovered that as the rover ran, it would pull to the side closest to the motor, kind of make it go around in circles. So they thought of the idea of using one rubber band's what they had. I'm going to use two on this one. We're going to flip it over. I'm going to take one side of an axle out, put our two rubber bands on it. Oh, actually, we'll run it through this way. Run it with our two rubber bands. And then through the other side, put the wheel back on. Then do the same thing with the back. I'm going to take one wheel off, come back here, put my axle through with the rubber band like so. Put the rubber band, make sure our gears line up again, and put our wheel back on. Now, if we're moving freely, we're going to try and make sure that our rubber band is not twisted. And basically what we're going to have here is a belt drive, all-wheel drive rover. There we go. Two rubber bands, and let's see what happens. We now have an all-wheel drive rover that slows down a little bit too. So that might be one suggestion that you would use. The rubber bands are something that you would have to source outside of the kit. But in doing that, it's going to put a little more friction on the motor itself, so it will slow the rover down. Another suggestion I would have for that is taking a piece of masking tape and taping the wires down on the bottom to keep the rubber bands from rubbing against the wires and possibly breaking the insulation on them. So something like this, and there you go. You now have an all-wheel drive rover that is a little slower, but it'll climb over some things. So there is building your Red Planet Odyssey rover for activity 2 in the Mars Base Camp Challenge. As your participants would design their obstacle course for their Red Planet Odyssey rover to maneuver through, the idea is for the rover to be able to direct itself as much as possible. That may mean it would bounce off obstacles and turn itself in a certain direction, but the least amount of human interaction with it as possible. Now, as I said earlier, you can use many things for developing these obstacle courses. You can use blocks, you can use books, you can use empty toilet paper rolls, you can use balls, anything like that you think you can make your rover either maneuver around, over, or through. One suggestion I would have is that you utilize their landing area from the previous activity to help them determine what their obstacle course is going to look like. Is it going to have craters? Is it going to have just strictly flat terrain? Is it going to have mountains of any type? Is it going to have a very rocky, uneven, bumpy terrain? And you can get that from the landing cards based on where their landing zone surveyor landed in the previous activity. Now, if they landed on a grid that they were in orbit around Mars, they won't have any terrain to develop, so they could just come up with their own, come up with ideas, or maybe take a combination of ideas from other landing cards that the other participants have. So Hope you've enjoyed the Red Planet Odyssey rover part of this Mars Base Camp Challenge. And next we're going to move on to the Crop Curiosity, where we learn a little bit more about growing food on Mars.